Moving on to lesson 5, day 2, we're still going to continue with negative exponents with powers of 10. Just we're going to dive a little bit deeper. So here we go, our goal. I know what it means if 10 is raised to a negative power. So let's see what happens when exponents are negative. So first thing, open up your workbook to page 27. If you don't have your illustrative math workbook, don't worry, you can still follow along. So page 27. Page 27 is going to look like this. You're going to see a chart going across the top here. We have using exponents, so we have 10 to the third, 10 to the second, notice they're going down. And then we have some blanks. We also have a decimal form, so we have 1,000 under 10 to the third. We have as a fraction 100 over 1 will be 10 squared. And so what we need to do is work through filling in these boxes. So as a decimal for this one would be just 1, so 1 over 1 as a fraction. This would be 1/100th as a decimal. What would that look like as a fraction? So we're filling in all our empty blanks. And also, you can see that as we go from right to left, we're multiplying times 10. So as you can see, the exponent of 1, we're multiplying that to get to the exponent of 2. We're taking another factor of 10 to make another exponent to gain another exponent. So probably the easiest way to do this, complete the table, explore what negative exponents mean. As you work, complete the table one row at a time to see the patterns most clear. So pause this video and try to fill in this chart as best you can. And then come back. We'll discuss. All right, let's go over some of these answers. So let's start with what we know, looking at our using exponents row. So we knew from 10 to the first, then we're multiplying times 10, goes 10 to the second, multiplied times 10, another factor of 10, becomes 10 to the third. So if we go backwards, we are really losing an exponent. So from 10 to the first, we lose 1. So really we're dividing by 10. We're going opposite direction. A factor of 10. This becomes 10 to the first. I'm sorry, 10 to the 0 power. If we go back, now we're talking negatives. And we're going to go back again to the negative second power. And back one more to the negative third power. So let's move on down to our decimal. So if we think about it, 10 to the third, that means 10 times 10 times 10. That's 3 zeros. We're seeing 10 times 10 times 10. So that's what our 1,000 is. If it's 10 squared, it's going to be 100. It's telling us 1 with 2 zeros. 10 to the first is just going to be 10. 10 to the 0 power is 1, which was given to us. And if you notice, our decimal, as we move from left to right, we are moving our decimal one place to the left as we go from left to right. So if we moved 1 to the left, that's how we get 100. If we're moving 1 to the left, that's where we're at 10. So factors of 10, all we're doing is moving that decimal. So now we're at 10, we're going to move 1 to the left, becomes 1. Now we have to fill in this blank, so we're going to move it 1 to the left, so it becomes 0.1. And then the one that's given, we're going to move it 1 to the left, becomes 1/100th, so 0.01. And then if we move it 1 more to the left, it's going to be 1,000th, 10th, 100th, thousandths. All right, so now our last row, we're just going to be filling in this number as a fraction. So if we have a whole number, which we do in this case, we're just going to put it over 1. So 1,000 over 1. 100 is a whole number, so it's going to be over 1. 100 over 1. 10 over 1. 1 over 1. Now this one is 1. We can just listen to yourself when you say it. This is 1/10, so it's 1 over 10. And this would be 1 over 100 because the 1 is in the hundredths place. And if you notice though, as we get into negative exponents, so we're going from -1 to -2, -3, where it becomes fractions, our 10, so we're keeping it as a fraction, our factor below is gaining a 0 each time we go to the right. So it goes 10 to 100th, hundreds to 1,000th. So watch for those patterns to help us along the way. And if you want to refer back to this chart as you're working, it would be very helpful. So as you move toward the left, each number is being multiplied by 10. So each one, as we're going, you notice our exponents are getting closer to 0, and then we're past 0, and we're going to keep on growing. We're multiplying by 10. What is the multiplier as you move to the right, though? We kind of talked about this. It's actually 1/10 we're going to be multiplying it by. So each one is going to be multiplied by 1/10, because 1,000 times 1/10 is 100. 100 times 1/10 is 10. 10 times 1/10 is 1. And you can keep on going. So each one's a multiplier. If we're going from left to right, it's a multiplier of 10. So if we know 10 to the 7th means in expanded form 10 times 10 times 10 times 10 times 10 times 10 times 10. There should be 7 tens here. 7 factors of 10. 1, 2, 3, 4, 5, 6, 7. So if we know that, and we know that 10 to the 7th power, if you put it in your calculator, you're going to get 10 million. Or we should know with 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. So use the patterns you found in the table to write 10 to the negative 7th as a fraction. 10 to the negative 7. So if we think of this, we're going to say 1/10 times 1/10 1/10 times 1/10 times 1/10 times 1/10 times 1/10 times 1/10. It's because we know that when we're dealing with negative exponents, we're actually dealing with fractions that we're multiplying by. We have to do that 7 times. So it's 1 going to be multiplied times itself 7 times on top. That's going to be your numerator. But then we're going to multiply 10 times itself 7 times, which would be 10 million. Or you can write it as 1 over 10 to the 7th, which is 1 over 10 million. So if 10 to the 5th is 100,000, notice in the table, 10 to the 0 power is 1. So 10 to the 5th has to be 100,000. So to do this, if we know 10 to the 0 power was 1, that means we're going to move it 5 places. So 1, 2, 3, 4, 5. And then we can come back and put our commas in once we move by increments of 3. 1, 2, 3, comma. 1, 2, 3. If there is another number past us, we put another comma. So using the patterns you found in the table to write 10 to the negative 5th as a decimal, so we know 10 to the negative 5th is, this is tenths, hundreds, thousands, 10,000s, 100,000s. So 1 over 100,000. So we're moving it. How can we tell this is to the negative 5th? 1, 2, 3, 4, 5. So, or we go 1, 2, 3, 4, 5. We go from left to right. I'm sorry, from right to left. 1, 2, 3, 4, 5. All right, so if we wrote 1 over 100 million using a single exponent, how would that look? So being it's in a fraction like this, we should know that it's going to be a negative exponent. And how do we know if it's going to be to what power? We can count how many zeros there are. So if we had to go 1, 2, 3, 4, 5, 6, 7, 8. So it's negative 8 would be our single exponent. So based on the patterns you saw in the table, what do you suppose the rule is for writing 10 to the negative n as a fraction? Think about that. So move the base of 10 to the denominator and make the exponent positive. That's it. So you're going to move the base of 10 to the denominator, that means the bottom of the fraction, and make the exponent positive. So what this would do, we're going to convert this 10 to the negative 6 into a fraction. So we're going to put 1 on top. We're going to bring the 10 to the negative 6 down to the bottom. But when we bring that negative 6 down, it now becomes positive. So our answer, so 10 to the negative 6 in a fraction form would be 1 over 10 to the 6. So when we convert it into a fraction like this, we're bringing our exponent down to our denominator. It makes it positive exponent. So look at 10 to the negative 15th. Make it as a fraction. So we're going to bring this base and this whole exponent down to the bottom. So move the base of 10 to the denominator and make the exponent positive. So it'd be 1 over 10 to the 15th. Notice they're opposites. It was negative, and now it becomes positive. To negate is to perform the opposite or inverse operation. So when we're talking about a negative 15, we want to make this into its opposite. We want to make this positive. We put it into a fraction. So now think of this as 10 to the negative 15 over 1. What you're going to do is inverse. So it becomes 1 over 10 to the positive 15th. So we like to write or simplify our answers so they have positive exponents. We don't like to keep our answers, our solutions in negative exponents. So to do that, we'll have to do some converting. So this is what we do. So our rule is if we have a negative exponent, so 10 to the negative exponent, we need to make that into a fraction to make it positive. Notice our negative goes away when it becomes a positive. So we're bringing our base down to the denominator, which now becomes positive. So how does this actually work? So 10 to the negative third. So we know that when we're talking about negatives, we're multiplying by 1/10. And we need to do that 3 times because that's what it tells us. 1/10 times 1/10 times 1/10. So when we do that, 1 times 1 times 1 is our numerator. And 10 times 10 times 10 is 10 to the third. And this now becomes positive. So we want you to open up your workbook to page 31, and we're going to complete number 1. If you don't have your workbook, that's okay. You can still follow along. So here's our examples. I want you to take a moment to write each expression with a single exponent. So if we had 1/10 times 1/10, being that we're multiplying these fractions with factors, this would equal a negative. When we want to look for a single exponent, this would become a negative exponent. So 10 to the negative second. So take a few minutes here, complete these 5 problems, and we'll work through them. All right, let's work through these. So we see 1/10 times 1/10 times 1/10. So we're multiplying 1/10 times itself 3 times. So that should tell us we're dealing with a negative exponent, and we saw the same thing to the third power. So it's going to be 10 to the negative third power. So when you write these using only positive exponents, so if we came out to be 10 to the negative second, we want it to come out to be 1 over 10 squared, or 1 over 10 to the second power. So I want to make this into a positive, and that's what I'm referring to. I don't want to keep my solution to be negative, so I want to make it positive, so I have to put it into a fraction form. So it'd be 1 over 10 to the third. So bringing our base down to our denominator, putting a 1 in our numerator, and that's how we make it positive. So in this one, we have 1/10 times itself 1, 2, 3, 4, 5, 6, 7 times. So it's going to be 10 to the negative 7th. And if I want to make that positive, so it's going to be 1 over 10 to the positive 7th. Okay, this one, we got a couple of different things that we need to do. First, we have to solve what's inside our parentheses. We're going to follow the order of operations, and then we have to take it to the second power. So in this case, it's 1, 2, 3, 4, so it's 10 to the negative 4th, and we still have it squared, or to the second power. So now we're dealing with power to power. We're going to if we remember our rules, we are going to multiply our 2 exponents. So negative 4 times 2 is negative 8, but if you remember, we don't want to leave this as a negative exponent, so we have to make it into a fraction. So it's going to be 1 over 10 to the 8th. So a few different things that we had to do in that problem, but not too bad. Okay, kind of same deal on this one. So we have 1, 2, 3 1/10ths in here. So it's going to be inside our parentheses. It's going to be 10 to the negative third. And then we still have this to the third power. So we have a power to power. So we're going to multiply those together. Negative 3 times 3 is negative 9. And then we want to make this into a positive. So we're going to make it 1 over 10 to the 9th. And then our last one. So we have 10 times 10 times 10, which would be 10 to the third. And we still have it to the power of negative 2. So we're going to multiply our exponents. 3 times negative 2 is negative 6. So 10 to the negative 6, we want to make this positive. So we put it as a fraction. So it'll be 1 over 10 to the 6th power. All right, I hope this is starting to make sense. If you are getting hung up, please let us know. We want you to try these. So how would you write these expressions as decimals? So let's look at 10 to the negative fourth. So take a moment, try to figure out how you would write these as decimals. All right, 10 to the negative fourth. We thought of these as decimals. So if we had this as, it's going to tell us we have to move our decimal. If our decimal is right here, our decimal is, right here, we're going to move our decimal 4 places. So if we would count 1, 2, 3, 4. So 10 to the negative fourth, it would look like that. So in this one, we have 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 10 to the negative 8th power. So that's going to tell us we need to move our decimal 8 places in front of the 1. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so we want you to try these. Write these answers with positive exponents. So take a moment, pause the video. All right, let's solve these. So we're multiplying exponents, so we need to add our exponents together. Or we're multiplying powers, so we have to add our exponents. So negative 6 plus negative 2, we have like signs, we add them together, we get negative 8. 10 to the negative 8, which we don't want to have a negative exponent, so I need to convert that into a positive exponent by putting our base and exponent in our denominator and a 1 as our numerator. So 1 over 10 to the 8th. When we're dividing powers, we have to subtract our exponents. So 3 minus 7 would be negative 4. So 10 to the negative 4th. Here, let's go. 10 to the negative 4th. And from there, we want to convert this into a proper form. So we want to make this positive, so I'm going to put it as a fraction. So 1 over 10 to the 4th. So if you notice, though, when we bring this base down to our denominator, our exponent now becomes positive. So looking back at the question above to prove this, so remember we're dealing with negative exponents. It's really 1/10. So we have 1/10 times 1/10. So we have 6 1/10ths and 2 1/10ths. So 1, 2, 3, 4, 5, 6. And then we have 2 more, 1, 2, and a total of 8. That's where we would get 10 to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. And then if you want to think of it as this, we have 10 to the 3rd, so 10 times 10 times 10. And then over 10 to the 7th, so 10 times 10 times 10. We do that 7 times. And what we can do from here, we can cancel things out. So we can cancel that one out, cancel that one out, cancel that one out. And all we have left will be, if there's nothing left, we just assume there's a 1. And we have 1, 2, 3, 4 left. So 1 over 10 to the 4th. Over here, when we're multiplying power to power, we need to multiply our exponents. So negative 4 times 9 is negative 36. We want to make that into proper form. So we put it as a fraction, 1 over 10 to the 36. And if we wanted to prove that, we could think of it as 1/10 times itself 4 times because it tells us, and then all to the 9th power. All right. So our big ideas for this lesson: multiply by 10 increases the exponent, multiplying by 1/10 decreases our exponent. Negative exponents can be thought of as repeated multiplication of 1/10. And positive exponents can be thought as repeated multiplication of 10. And multiplying by 10 or 1/10 affects the placement of the decimal. All we're doing is moving that decimal. So once again, to review what we learned today, I know what it means if 10 is raised to a negative power. So that's it for today. We want you to head on over to Schoology and complete today's practice. And you can let your teacher know if you have any questions. Hi, Lizzie.
Hello. Can I do my...
So I can see, Lizzie. I didn't get anything back yet, but I can see if that YouTube. See if that YouTube is up. They have not seen it yet. I would be able to see if they looked at it. Okay, negative exponents with powers of 10. I didn't think you guys would be back so soon. Negative exponents.
The bus came early today.
I should see what Shelly's.
Yeah, do you want, I did, I forgot what I was gonna say. I thought you were being in the basement.
Well, I didn't think you were going to be that fast, so I thought I could